Well, good morning, everyone. Welcome to this session. My name is Dave OudeNijeweme, and I'm from the Advanced Propulsion Centre. So welcome to this third event in the Road to COP26 series, where we'll be looking at enablers to meet net zero. So today we'll be talking about electronics and how these hidden devices literally control the pathways to net zero. So I'm not an expert in this field, but luckily I have a panel of experts with me here today. So first of all, we have Martyn from the Department of International Trade, who will provide a keynote. Then we have Matt Boyle, OBE, from Turntide Technologies. We also have Dr. Martyn Cherrington from Driving the Electric Revolution, David Bock from BMW, Sarah Mlundira from XP Power, Dr. Graham Bruce from RollsRoyce, and hopefully we'll have Dr. Kimmo Rauma from Danfoss as well to finish things off. So over the next hour and a half, this panel will provide you with a keynote and some shorter presentations with a Q&A and a discussion session at the end. Please do ask your questions at the end in the Q&A, or during the session at the Q&A box, and we'll come back to that. And any general questions in the chat function, please. Your microphone and camera will be off for duration. So electronics, well, it basically touches everything that we do. And that's really not an understatement. Anytime electric energy is converted into voltage, either higher or lower, or between AC and DC, converters are required. And on a more macro level, and certainly at higher powers, we need power electronics, and I've just put this together as a rough idea on where this is in the wider picture. So in an energy system, I've sort of roughly represented where clusters of power electronics live throughout this piece. This is a very much of a simplification. But as you can see, it touches all aspects of our life and are critical to the road to net zero. So with more distributed power generation from more sustainable energy sources, including wind and solar, but also with more use of electricity, cars, heat pumps, etc., we'll need even more power electronics. And efficiency here is key. And therefore power electronics are so important because they are the gatekeeper for efficiency. And just by example, looking at a car, I've got the simplest representation of a car. But there are three major power electronics pieces on that car: battery charger, DC to DC converter, and an inverter, and maybe some other bits around that. But those are the key power electronics. And their efficiency are instrumental to and have direct implications to the range of that battery electric car. So that is really, that is sort of, to my mind, the simplest format of demonstrating the importance of efficiency in power electronics, because it touches not just the car, but everything from generating electricity to the end use. So before I hand over to Martyn, I'd like to briefly reflect on why it's so important to get to net zero and why COP26 is so important in that journey there towards. So my drive doesn't come from my boss, popular to contrary, to popular belief by my boss, I suppose, but my drive really comes from my 12-year-old son, who challenges me on a daily basis, and I'm not joking here, on a daily basis, what I have positively contributed to this quest to net zero. And I just wanted to start with that, because I think that is what sets this quest so apart. Anyway, with that, I'd like to hand over to Martyn Wood, who is the Zero Emissions Vehicle Supply Chain Specialist at the Department of International Trade. Martyn, over to you.
Thanks very much, Dave, and welcome to everyone attending today's webinar. Just wanted to reflect on what Dave said at the end there, because it's very much from the heart in terms of his 12-year-old son, and I feel, for me personally, I feel exactly the same. This is a mission of the heart, and it's a mission to leave the planet for the next generation in as good a state as we can. So I reflect and feel very similarly along those lines. I'm sure many of you dialing in and many of the other panel members feel the same. So the automotive sector is at the heart of this transformation. The automotive sector is a big, let's say, supplier of emissions that we're trying to take out of the UK environment, out of the world environment. So our challenge is very much to transition that sector. And it's a sector that is vitally important to UK government and is at the heart of industrial policy within government. You see figures from 2019 in front of you on the slide. The sector generates over 80 billion of revenues. Over 80% of the vehicles we make are exported, a true global industry, and R&D spend in the auto sector is approximately 10% of overall UK R&D spend. So vitally important and a purveyor of skills and talent and intellectual property. And as we transition and as we transform the sector, policy intervention is for sure necessary and supports business by giving surety and giving a long-term view. And as with the Road to Zero strategy, where from 2030, no petrol and diesel cars or vans will be sold except for a certain few types of hybrid vehicles where there's a 5-year window. That policy is giving surety to the market and it's giving leadership. And we've noticed that this leadership is being picked up by other countries and working alongside us side by side. And the Road to Zero is very much part of the UK government's 10-point plan, which is an investment in a number of key areas of our economy to support our legal commitment to get to net zero by 2050. And just focusing on the box in the middle, I've already talked about the vehicle sales change in 2030. Alongside that policy intervention, there is cash support or grant support for businesses looking to invest and supply components into this emerging sector. And we've also accelerated the rollout of EV charging infrastructure with a 1.3 billion figure. The Automotive Transformation Fund, the first £500 million has been released of an up to £1 billion fund. I think it's worth just reflecting though that beyond this shift to zero emission vehicles, there is a comprehensive policy programme sitting around the sector specific. So for example, advancing our offshore wind investment is clearly vital if we're going to implement and install industrial processes that are energy hungry. It's clearly important that we power those processes using true renewable electricity to give a full renewable picture for the long term and as we started at the head of this webinar, for our children and our children's children. So what are the interventions that UK government has in place, or what's the support that's in place for R&D and industrialisation? Sure, driving the electric revolution, you'll hear more from Dr. Martyn Cherrington later, and I won't steal too much of his thunder. But 80 million of government support for EV motors and specifically here power electronics. There's also further support available for the Faraday Battery Challenge, which you can see 318 million. And through Dave's organisation, through the leadership of the CEO Ian Constance, there's been a huge amount of success in deploying matched R&D funding, which is to the tune of over £1 billion by now through the core programme and the Automotive Transformation Fund I've touched on. I just want to give a very, very brief introduction. Please don't be too afraid, Martyn, for DER now, just with one slide. Next slide, please. And driving the electric revolution is very much a comprehensive programme, and it's not just for the auto sector. It's truly cross-sector, which, going back to my point about wind energy, must be really exciting. I just wanted to pick up one point of from the DER program of work, which we'll hear more from Martyn later in the presentation, which is around talent. Because for sure we have to transform and encourage new people into this sector of work to fulfill our needs and our requirements into the long term by upskilling people, by training, by reskilling, and frankly by inspiring people to enter this field of work in power electronics, machines and drives. And of course the UK is well set with a very much a thriving R&D environment, and we've just picked up on here in some of the auto-related R&D. There's many sites dotted around the UK. You can see the small blue blobs. So in every part of the UK, we see R&D taking place. And of course, we are very privileged that we have 18 of the world's top 100 universities set here in the UK.
I think we might have lost Martyn briefly. I think he had some technical issues previously. Okay, in which case, I think I might have seen some of these slides before, so maybe move on to the next slide, please. So what Martyn would typically say here is that apart from universities out there, there are also a number of Catapult centres around the world, very much modelled on the Fraunhofer institutes. And one of those sets is the high value manufacturing catapults, with 7 advanced R&D centres dotted around the UK, and they really have great capabilities and try and link those capabilities to industry as well as academia, and link those two sectors together.
Am I back, Dave?
Oh, you are back, yes. We're just on the manufacturing technology centre.
Yeah, I can see it in front of me. Sorry, I had a timeout message at exactly the wrong time, so apologies to everyone, but no problem. Dave and I presented side by side on a lot of this material, so I'm sure you were in good hands. So within the HVM network, there's a picture of the MTC here. MTC, many of you will realise there are scale-up electronics production lines in MTC, so pick and place equipment. Also, I just wanted to add that we're really well served with the CPI Catapult around flexible and hybrid electronics. So there's really deep support for businesses that want to innovate and want to scale up and industrialize. And just to touch on some excellent support that's available outside the HVM network. So another Catapult, the compound semiconductor application Catapult in the cluster there in Newport in South Wales. So 53 million of funding over a 5-year period, been up and running for 3 years now. And the Catapult is very much there to support businesses that wish to commercialize opportunities in semiconductors, in power electronics. There's various laboratories, various specialist resource within the Catapult, working side by side with business to really deliver that scale up and to deliver that opportunity for the sector in power electronics. Remembering and repeating what Dave said at the head of the webinar, when you look in a vehicle, there's power electronics controlling the drives and machines, there's power electronics controlling the battery, the state of charge, balancing power across the vehicle. So it's a really very interesting market, some great opportunities, and the UK has some really leading IP that we would wish to support the development of. So I just wanted to finish off with a few recent investments to share some good news. I think we could all do with some good news in these times, and we were delighted to be able to confirm Nissan investing in their EV hub in the northeast, with Stellantis investing to convert Ellesmere Port to an all-electric vehicle portfolio. And then to some less obvious but equally important, certainly strategically, Teva unveiling their electric truck only last week, and the Automotive Engineering Centre unveiled at Myra in the Midlands. And why are these important? Well, these are important because this is the market. This is the market pull for the products and services that companies operating in this space. And I just wanted to pick a few others that hopefully they're not just personal interest to me, but I think they're strategically significant. And apologies for not including all announcements of good news over the past, let's say, 6 to 8 months. But these were things that I think are pretty important. So Pensana and Peak Resources, rare earth material, again, motors, heavily connected with their power electronic cousins. Matt Boyle's Turntide organisation, integrating 3 organisations in the Northeast to deliver power electronics, motors, battery electronics into the industry. Extremely exciting investment there from Turntide. And I think this was perhaps 2 weeks ago. There's a picture of John Beasley from APC, from a picture he kindly sent me. They're operating a manual shovel, let's call it, rather than the automatic shovel in the background. So the groundbreaking on Danfoss's facility in Scotland, which again, demonstrating this is a true UK play. So that's really what I wanted to just address today. Apologies for getting interrupted as I was getting into full steam around skills and talent. I think perhaps you got the message that this is where the UK has a clear advantage coming out of universities and out of some great research organisations, and where we really need to build on that to inspire the next generation to join the mission through the university technical colleges and other colleges around the UK. So thank you very, very much for your time today. It's something I'm very, very passionate about, and I'm very pleased to be here today and share that passion with other passionate people on the panel, but also the audience. So thank you all, and thanks Dave.
Thank you, Martyn. Despite the interruption, it came up very, very clear. And you've done also my introduction to Matt Boyle now, even with a photo, so that's fantastic. So Matt, really over to you. I think you devoted quite a bit of your career to electrification, and I think your latest venture in Turntide is very, very exciting. So please take it away.
Thanks, Dave. I think building on what everybody said so far, you have to understand that power electronics, machines and drives are the ubiquitous underpinning technologies that will address climate change. And as Dave's already said, it's been an entire working lifetime working in the field of electrification, from very large diesels through to milk floats and hypercars. But the common theme throughout it all has been this need for power electronics, machines and drives in the sectors that both Turntide and prior to that Sevcon, Avid and Hyperdrive have been addressing. And that's because without these technologies, you cannot address climate change. And I'll come on to show you how that's true in a second or two. But I think those of you who have been on the call or before with people like me, we're evangelists for this stuff. But the real issue for us is that we want Britain to succeed in supplying the solutions to this stuff. And there have been several market failures over the years, and it's in no one person's bailiwick to solve this. So government, industry, and academia need to come together and work in collaboration to address the issues of power electronics, machines and drive supply in the UK. But industry needs to fess up. It needs to be the lead throughout this, and it needs to fund innovation. And we'll come on to how in the recent past that's been a substantial success for industry and why you should build on that. And then last but by no means least, for all of those of you who know me, manufacturing at scale of this stuff is something we want to do here in the UK. Not because we want to do less of it elsewhere, it's because the pie is substantially bigger than it was. It also requires in these various disciplines a great deal of automation and to be successful. And that's why I think the UK can compete with quote lower cost manufacturing locations. And it's starting. You've heard a couple of times about driving the electric revolution. That is helping supply chains build in the UK. But the supply chain in the UK, it has to be said, is nascent and needs substantial investment, but it's beginning. I mentioned to you why and how power electronics machines and drives are essential in addressing climate change. These numbers are from the EPA, and they're the 2018 US greenhouse gas emissions by sector. Now, this is US only, so treat it with that health warning. However, it is very similar picture across the globe. And what you see is, in the kind of 6 sectors on the left-hand side, transportation, which I split out specifically, you see that 98% of the emissions of transportation can be addressed by power electronics machines and drives. And they include things that are already being electrified, as Martyn's already said, things like light duty vehicles, medium and heavy duty trucks, cars, but also aircraft, rail, ships and boats, also a component of that transportation segment. And when you look in the graph on the left, in the pie chart on the left, you see that outside of transportation, you get electricity, industry, agriculture, commercial and residential. And when you look at that particular set of sectors, 90% of the emissions of those 6 sectors can be addressed by power electronics machines and drives. But that says you need power electronics machines and drives to address electrification and to address climate change. So I mentioned innovation and how industry has actually been very, very successful in innovation. I'm not attributing this simply to Apple. It does look like an iPhone. It's not simply Apple. It's everybody who uses a smartphone. You've replaced the stuff that's on the right. You have apps that turn your phone into a camera. You have apps that run and create a radio for you if you want it. But what you've done in moving from all of those individual devices to the device on the left, the smartphone, is you've saved an enormous amount of carbon, an awful lot of emissions, because you no longer, and I've been a road warrior for the best part of 30 years, and I can tell you, my back is bent because I used to carry about all of this stuff. I now just carry a smartphone. And that's where innovation actually does make a difference. And it is about asking the question, what more can this solution do for us? And this is the last one. The opportunity is huge. I mentioned earlier on about, this covers more than just cars. Power electronics machines and drives are the solution to the electrification there are 7 sectors on this slide. So they include automotive and on-highway. They include energy generation and distribution. They include industrial and off-highway. They include marine and rail and aerospace. Power electronics machines and drives, if we can apply them properly and manufacture them at scale, are the only thing that's going to help us get to address climate change on the whole. Thanks very much.
Thank you, Matt. Very passionate plea again. So that's what we're expecting. That's really good. And I think it now broadens it up to, away from automotive to the wider, not just use, but also how you make these, make electricity and transport it. So with that, Dr. Martyn Cherrington, who is the innovation leader driving the electric revolution. So please, Martyn, over to you.
Yeah, thanks very much, Dave. Good morning, everybody. So I was going to start by reiterating Matt's first comment. So net zero is not achievable without increased electrification, and electrification is fundamentally not possible without power electronics. They are part of the critical suite of enabling technologies alongside machines and drives. To demonstrate this bluntly and rather controversially, perhaps, the batteries in your electric vehicle are essentially expensive lumps of chemicals without the power electronics to condition the electrical power going in and coming out of your cells. Power electronics really are fundamental. And the ever increasing interest in electric technologies is really driving this global boom in demand for advanced power semiconductors. But as well as driving this demand, it's also driving innovation in this space, as Dave said, his introduction, to improve system efficiencies. And we should ensure that the UK remains a world leader in developing next generation power electronics technologies. The issue, however, is that when it comes to manufacturing power electronics, the UK is currently heavily reliant on overseas supply chains, and certainly going forwards, we really must look to manufacture these core technologies and develop resilient supply chains in the UK, ultimately putting us in control of reaching and achieving net zero. And this is where the Driving the Electric Revolution challenge comes in. So Driving the Electric Revolution is a challenge programme funded by the UK government and has been delivered by UK Research and Innovation, and is identifying key gaps in the UK PEMD supply chain and helping UK industry to fill them. So we are investing £80 million of funding for both collaborative research development projects and also for open access facilities for industry to use to accelerate and de-risk this business innovation. So our focus is very much on the industrialization and the manufacturing, as we seek to leverage this world-leading research capability in PEMD that the UK has to create the supply chains necessary to manufacture PEMD products. And to Matt's earlier point about coordination market failure, we are working across the whole manufacturing supply chain, from materials through end-of-life recycling, and across all sectors. As you saw from Matt's final slide, all of those sectors undergoing significant electrification. So this is across energy, transport and industry, to try and break down the silos between these sectors. And it's this connecting of industry, research organisations and the government that ensures this effective cooperation and collaboration to hopefully facilitate the UK capturing this maximum value from these PEMD solutions, and will help us achieve net zero. So to date, Driving the Electric Revolution has funded 14 supply chain focused, industry-led collaborative R&D projects in power electronics out of our current project portfolio of 40. And these projects cover the majority of the supply chain in power electronics. So whether it be innovative front-end process developments in projects such as Slogan, which has developed processes for gallium nitride HEMS, through to state-of-the-art back-end processes such as novel die-attach processing of GaN and silicon carbide dies in the GaNSiC project. And these projects represent an investment of £3.6 million from the challenge, but with industry co-investment, this total value is in excess of £6 million. And we certainly expect this investment to increase when we will be announcing the results of our recent funding competition, Supply Chains for Net Zero, in late autumn, following the COP26 event. So Driving the Electric Revolution has also invested £33 million in the Driving the Electric Revolution Industrialisation Centres, or DERIC for short. And DERIC represents the coordination of a UK-wide network of 30 open access facilities in world-leading research organisations for industry to leverage expertise and utilise and accelerate process innovations to develop UK manufacturing supply chains. And much of these power electronics activities are being delivered by the South Western Wales Centre, which is coordinated from the Compound Semiconductor Applications Catapult in Newport. So in summary then, so Driving the Electric Revolution is working to coordinate and develop the supply chains that will help deliver net zero. Emerging power electronics technologies are very much on the journey now to being industrialised due to strategic UK government funding programmes, such as Driving the Electric Revolution, but also APC, Aerospace Technology Institute and others. And certainly in terms of things like gallium nitride, we have a very well developed now front and back end supply chain, and certainly the same is also becoming true in silicon carbide. And ultimately, as a final point, coming back to what I said at the beginning, the bare fact is that net zero will not be realised without power electronics and machines and drives, else there will be no electrification of energy, transport and industry. So with that, thank you very much, and back to you, Dave.
Thank you, Martyn. That's great. Thank you. With no further ado, I'd like to hand over to David Bock at BMW. David is a technical lead at the BMW group, and so we're going firmly back to automotive, then we're coming back to the power generation side of things. So please, David.
Thanks very much, David. So Dave Bock, I've been working at BMW for about 10 years. I've been in power electronics and electrification of vehicles for over 20 years now. So I've seen there's been some quite interesting developments, and I think a lot of that has come in the last years. We're very lucky to be running the project from our plant in Oxford. We have some very strong partners helping us develop our electric vehicle powertrain. It's quite interesting because I'm hearing and seeing names that are popping up quite often. So we are partnered with CSA Catapult, and I'm sitting with one of my colleagues right now. We have an industrial link through Custom Interconnect Limited. We're working with the University of Warwick and Lyra that is part of, as Martyn said, developing the talent and the capability of the UK to deliver these technologies. So I think that's a really interesting point from Martyn, that it's not enough just to deliver solutions. We have to have the talent development to make sure that those people are available in the future to continue delivering these energy classes. I've got a couple of very exciting corporate slides that I will promise will be very, very fast. BMW itself is very committed to reduced emissions. We have a very strong path towards a sustainable future. We call it our race to zero. And one of the things on this is we are in discussions for aligning with the COP and also sustainable innovation. BMW also recognizes that there's a change of energy. So it's not just about battery development. We have to be ready for other energy sources. But right at the heart of that, regardless of where the energy is coming from, is the power electronics. So BMW says that by 2025, we have the new class of all of our powertrain, which is electrification ready. And we think that will reduce our emissions of the vehicles by 40% over life. So that's a big commitment from the business because they recognize their responsibility globally. So to the stuff that I'm interested in, so my background is power electronics, and that's what we're delivering. And we're looking at these architectures. What's important for automotive industry is traditionally we have a very long cycle time from concept to delivery of the solution. So through our At Future BEV program, which is partly APC funded, we are looking at mechanisms to accelerate those technologies to the vehicles. We also recognize it's important, BMW says sheer driving pleasure, and it's important that the customers want it, because if the customers aren't interested and excited to take the products, it's just a grey box and nobody will take it. So we have to keep not just the engineers enthused to develop these technologies, but the customer enthused to take the technologies. And this is a very important message, because I think it's by 2030, we want half of our vehicles to be electrified. That's sort of aligned with what the UK government is doing. And we're looking at technologies for improving the efficiency. So our next generation power electronics will increase the voltage of the platforms. So we're going up to 800 volt systems. One of the enablers for this is development of new switching technologies like silicon carbide. Within our program, we're very deep in this. So we are looking, one of the mechanisms we're looking at to enable this is development of a standardized module, because the biggest pain we have is there is no such thing today for these high power modules. And for the automotive, my background is power electronic engineering, and I always say that 70% of the inverter is mechanical, actually. So I always have a very good mechanical engineer sitting next to me, because if you can't integrate it, it doesn't fit in the car, you don't build the car. It's fairly black white, and that's fairly a simple message from us. So I think that's it for the slides. And I'm very enthused to be working with these companies in the UK, because I have come over from Germany to run the project. And I think BMW is showing a strong commitment in developing a team. So we're doing a lot of training within our program to make sure that those high efficiencies do come to our vehicles. We've traditionally leaned on the fact that, of course, electrification is more efficient than combustion, old bang, squeeze and squirt. We're now on converting electrons to traction. But we need to do it in a mechanism that squeezes out those last few percents. And it may not be about silicon technology, it may be about software. So I think there's still, it's a really interesting market. Additive manufacturing is coming in. So I think better ways to do cooling, better ways to build the modules, And I think we have a really strong future. And there's still, we've taken all the low-hanging fruit, but now develop that talent, get the talent pool out there, and really start squeezing those last few percentiles in to make sure we make the best use of the energy we have available. Thanks.
Thank you, David. That's really much appreciated. It's great to hear from a visionary company like BMW and how they address the big challenges that are out there. We're running a little bit behind time, so I'll hand over to Sarah now. Sarah is head of quality for Europe at XP Power. And please, Sarah, I think you're going to talk more about the power generations. Please take it away.
As my fellow speakers today have mentioned in various ways, how science and technology and UK collaborative research and development can ensure our net zero emission targets are met, and in particular, how power electronics are controlling the pathway to net zero. I just want to reiterate on some of the points that they have mentioned today. But first of all, my background is briefly in power electronics for automotive, but mainly in power electronics for renewable energies, in particular, power conversion for wind turbines. And now my current role is in the design and manufacture of power supplies used in various applications, including rail, aerospace, medical, semi-fab, and others. And the commonality in these several areas is the use of power electronics to convert power from a source to energy that can be used by end applications. And as our energy consumption is ever increasing, power electronics will play an even bigger role in controlling the pathway to net zero. So I just want to go on to one of the COP26's key objective itself, which is to secure global net zero by mid-century and keep 1.5 degrees C within reach, and achieve this by tackling 4 key areas. That's to phase out coal, to switch to more electric vehicles, and invest in renewables, and finally to curtail deforestation. Well, power electronics is at the forefront of the technologies that will help us tackle these 4 areas. Power electronics, for instance, is required for the advancement of electric vehicles. But with us increasing the number of electric vehicles on our roads, it goes without saying that our energy consumption will inevitably increase. But to really achieve that net zero, the source of this energy will have to come from zero carbon sources, such as renewables, and not from coal. As we invest more in renewables, power electronics will inevitably also become more important in order for us to interconnect the several energy sources to supply to our end users. So I read an article once that mentioned that Germany developed a concept called sector coupling, which refers to increased integration of energy supply sectors and energy consuming sectors, but not just in Germany. Sector coupling is well known and accepted as an important strategy to deliver decarbonization and other objectives such as security of supply and affordability. One such example of such sector coupling would be in renewable energy and electric vehicles. So this solving of our net zero would not just be for single sector like power electronics for electric vehicles that would ensure that we have more electric vehicles on the road, but also we need to solve them together. So sector coupling would help with that. So in that case, it would be, as most of the renewable energy sources are solar and wind, and these major sources are not always available, and storage of this energy will be very important. Electric vehicles can help by solving this problem in storing this energy in their batteries, and when there is excess on the grid, and then when there is not enough on the grid, put it back on the grid. In order to do this, we don't only need advanced technologies in energy storage in batteries, for instance, but also in power electronics required to convert that energy from the electric vehicle and back on the grid, and vice versa. So, but whether you agree with using your future electric vehicle to store energy in order to solve the problems with the grid when there is fluctuations of energy on the grid or not, one thing is for sure, and one thing is for certain, that working collaboratively across sector will help us in UK in order to achieve the net zero, because we can leverage on the knowledge that has already been in existence in power electronics for wind turbines, because they've had power electronics and power conversion for longer than automotive has. But also automotive offers a different spin on things, because their driver is different. They're looking for reducing size, weight, power density, efficiency, and hence have moved rapidly in emerging technologies. And together we can leverage on the synergies that we have in the design and manufacture, and not just design, but also manufacturing. So I think that the other point I have here, which is on cartel deforestation, even that in itself can be solved by power electronics itself. I am from Malawi, where most of deforestation happens because it is used as a means of energy. And if in UK, through collaborations and the knowledge that we have over the years, can not just solve the problems we have in Europe, but also solve the problems that developing countries have in developing power electronics, ways of converting energy at a very cost-effective price for developing countries as well. With that, I'd like to thank you for your time and hand back to David.
Thank you, Sarah. That's really great. I like your view on things, and I think that developing countries element is key. It's all very well saying one way or the other, but it is net zero for the whole world rather than just a few. With that, I would like to hand over to Graham Bruce from Rolls-Royce. Graham is an electronics specialist at Rolls-Royce. And I think, Graham, you're not just going to talk about aero, I hear, but also about power generation.
Okay, so Rolls-Royce, from the top, we're a high technology engineering company. We design, develop, manufacture and service integrated power systems for use on land, at sea and in the air. As a group, we're split into three businesses: civil aerospace, defence and power systems. I think I'd like to say, as an electrical engineer in a traditionally mechanical engineering company, electrification really is a key strand in all three businesses today. And that's a key strand also in our pathway to net zero. You may be aware that we joined the UN race to net zero last year, and we're playing a leading role as we move forward in enabling the sectors which we're a part of to reach net zero. But that's not just decades away. We've already started. So if you look at our civil aerospace turbofan engines, you can see a picture there. We've already run one of those on 100% sustainable aviation fuel, and we've pledged to get all of our current in production civil engines achieving the operability with 100% sustainable aviation fuel by 2023 as well. So we're on the road. A couple of little nuggets that you might not know about Rolls-Royce: we're the UK's sovereign capability for the nuclear propulsion system for the Royal Navy's submarine fleet. We're also developing small modular reactor capability with high UK content for land-based power generation, which is a key element in the pathway to net zero. And in our power systems business, which is based out of Friedrichshafen in Germany, microgrids and land-based generation are already a key pillar there. But I'd like to highlight our 1 to 4 megawatt hybrid electric power packs, which are now seeing use in trains and even in the odd Sunseeker yacht. And so to aviation and the electrification of aviation, there's two major dynamics. There's the evolutionary, which is the so-called more electric aircraft, taking existing mechanical, hydraulic, pneumatic systems and introducing electrical equivalents which have greater flexibility and better efficiency overall, so allowing us to transport ourselves around the world more efficiently. And then there's the revolutionary, which is really about the use of electrical power for propulsion itself. And in this area of the market, we're really seeing the disruptive opportunities at the smaller end of the market presently. So in urban air mobility, perhaps, and small commuter aircraft. In fact, the image you can see there is a UK collaborative project. The aircraft is Spirit of Innovation. It's just taken to the skies last month. And hopefully, towards the end of the year, we'll see that attempt the electric aircraft speed record in excess of 300 miles an hour. So it's an exciting space, an exciting time to be in the business and the industry. So moving on, if I may, and zooming in a bit more, talk about power electronics machines and drives. So there's a couple of challenges that are really pertinent in aerospace for ourselves. Power electronic systems are complex by nature. They don't have the same failure mechanisms and repeatability, so repeatability of failure, if that's a good term to use, as we might see with a simple mechanical part. And so we've got to be very careful in how we deploy these systems to get the appropriate availability. And ultimately for ourselves, fault tolerance is a key enabler. And we've been working very hard to make sure that our electrical system solutions, you can see some of our first generation hardware here, is truly fault tolerant. Alongside getting the functionality for these safety critical functions, we have a list of environmental challenges, which are in some instances more pronounced than what we might see in terrestrial systems. And so you can read those on the left, obviously, but just a quick example, a little nugget. So you can see here a small turbofan engine preparing for a fan blade off test. So in the event that a fan blade might be released from an engine, it must be radially contained for obvious reasons, but any equipment, any electrical, electronic equipment and accessories that are attached to this engine must also be intact, and we must be able to run this engine down safely. So being able to achieve these other objectives as part of a system is quite a challenge. So zooming out again and thinking about the ecosystem, the future of aviation could be very different to what we see today. One thing's for sure, power electronics, machines and drives is an essential ingredient. There's some significant challenges that do exist in deploying the technology, particularly at megawatt scale, which is required for some of the larger applications. But we're building upon today's experience in the industry. We're also working with new supply chain partners and leveraging cross-sector developments from programs that the APC have been heading up, and also working with Driving the Electric Revolution and really getting the best from across the power electronics industry. So I think that's all I wanted to say there, apart from a quick plug, if we may. We shall be at COP26 in the Green Zone and the Science exhibit. So if you do join us there, you're more than welcome. Otherwise, I'll hand back over.
Excellent, Graham. Thank you very much. Good to hear that you're working on zero carbon flights, because I'm missing the sun and we can't fly at the moment because of my son, of course, who's not willing to fly at the moment. With that, I'd quite like to move over to Dr. Kimmo Rauma, who's the Vice President from Danfoss Editron. So Kimmo, with no further ado, please join us.
So my name is Kimmo Rauma and I'm the VP on Power Solutions, which you can see from the left side, and there I'm leading the area of mobile electrification, and I will show you a little bit on the Danfoss structure. My background is in power electronics. I have been entrepreneur for most time of my career, running 8 different companies, and as I say, I have the most expensive MBA in the world, as bankrupting and losing everything on that one. And then lately some success with the other companies, and through that Danfoss acquired my company, where we focused really on the off-highway electrification. And now since 4 years have been leading the division of mobile electrification, which is called Editron in Danfoss. I have a PhD in console engineering, so that's my technical background, but more or less have been on the management and leadership side of the things. Tero Järveläinen from our side, CTO, was supposed to be presenting, but as we have one of the top truck manufacturers in visiting of our site, and we are working for electric trucks, I decided to let him to be focusing on the customer and I do the speaking, so we both use our benefits to the best way. So that's why you have me today here presenting. But okay, let's go to the topic. Danfoss is a family-owned company with almost 8 billion of revenue annually, and it's divided 3 segments: Danfoss Power Solutions, Danfoss Climate Solutions, and Danfoss Drives. And just starting from the right side, Danfoss Drives, we are focusing on industrial drives, and we are second biggest in the world for power electronics for the industrial drives. And also we are focusing there on the power modules which are used in the automotive. So at the moment we have about 30 million cars using our power modules, and also we are heavily focusing on silicon carbide, and we have released the products for that one, and quite many of the automotive suppliers are using the next generation the power modules from us, and probably the latest announcement is with ZF and Volkswagen there. And then we look to the middle, that's climate solutions. We are #1 in heating solutions in buildings, and of course a lot to do there with the green energy and getting the climate change stopped. But today we don't focus on this segment. And then on the left side, we are the biggest or second biggest in the world for hydraulic powertrains in all mobile equipment in the world. We also have some industrial part. We just lately acquired Eaton Hydraulics, which is part of this. And then we have the division which is focusing on electrification, where we do the drives, motors, systems, and energy storages for the mobile applications. Technology side, we should belong to the drive side, but as we want to be close to the customer, we are focusing in the customer servicing part, and that's why the electrification of mobile applications is hosted by the segment of Power Solutions, and we are there on the independent division with own profit and loss account, and that's my job daily basis. In the Editron, we have 3 business units. The business units are focusing on off-highway, on-highway, and marine. So all of the things that we are talking here today. Here in this slide, we are mainly focusing to the on-highway part and to the trucks, as this is related to our program with ABC in UK, where we work together with Meritor, which is the single independent manufacturer of axles in the world. So they are the biggest one, which is not owned by any OEM. So we have a program here with APC together, and we are focusing really to tackle the issue on the heavy duty trucking. And why there needs to be new things done is because there is no electrified axle today that can really meet the needs of the OEMs. And this is because of the integration level, efficiency level, and of course the cost level. So we need to tackle all of these to be really competitive in this world and being going forward. The areas of truck are of course the battery, the vehicle integration, the total efficiency, and then coming to the power density. But giving an easy example to everyone here is that every % unit that we lose after the battery in any vehicle is out directly from the main investment in the battery, which is the single biggest investment in any electric vehicle. So it means that if we have 100 kilowatt hours of batteries in a truck, and we have a 99% efficiency in a drive after that, we have lost 1% unit, which means that we have lost 1 kilowatt hour of battery in our use of the truck. And if it's costing 500 euros, that's the investment of capex 500 euros. And if you could increase the efficiency by 1%, you could use that capex wise directly on top of it. And then of course in the OPEX, it's helping as well. But now when we talk about our target in this one is really that the axle, what we create is better to use because the efficiency improvements for the OEM are so big that actually the payback time comes directly from the capex, what they save on the battery, because the increased efficiency is so high level here. And secondly, the vehicle integration, the power density is so high that everything is packaged into one axle and can be directly utilized in any truck. Thirdly, we are going to the full integration through the mechanics and using the silicon carbide power modules. And I will come to that how the efficiency is improved on those ones. And then of course, when we really put everything together, the cooling comes the most important factor. And as already heard from the BMW, it's the fact that it's more about the mechanics and cooling than the actual electronics there. Of course, taking into consideration that we already have the silicon power module from Danfoss, which is certainly the best one at the market today. In EPIC, which is the name of our APC program, we are really creating this new powertrain to the market. And also we are creating the products for Danfoss that we can serve to any other players in the off-highway or marine industry, because these will serve then respectively to those markets on top of the Meritor program. Here is the picture out of the product, just to show you that it's 800 volts DC, 1300 amps, and it's packaged inside 24 liters, and which this gives you about 50 kilowatts per liter as a density, and you can see the program there. This is designed and will be delivered throughout the APC program, and APC is really a key key part that it is established and put together in UK, and through that we have, as you see already from Martyn's slide, that we have opened up the new development center in Edinburgh, really to focus on this area and putting these things in UK. And it would have not happened without this partnership with APC and Meritor together, where we are tackling this part. And now the efficiency, to have a little bit also really power electronics facts here, that not only saying that it's important, but really to see why it is important and how big the difference there is, and also to remind you about the lost percent units in the powertrain is directly out of the investment in the total powertrain capex. From the right side picture, you can see a typical truck motor torque, and now it's put into the torque so that everyone can see that it's on the truck. So you can see 1000 Newton meters as the top peak there, and then you can see the comparison between standard silicon and silicon carbide, and that's actual percent units. What is the improvement there? And you can see that you get almost double out of the silicon carbide. So the losses are 70 to 80% smaller when you go to silicon carbide. And now you can go back and see that investment to this technology really pays out, because you get it from the powertrain and from the battery. And this is really important to remember, that even you are investing almost double to the silicon carbide compared to silicon, you get it out in the total system level. And I think that's an important thing, that the system design is the most important to get actually the efficiency and the improvements out. And that's why when we are developing the whole system together with Meritor, gives the extreme output from this program. Hopefully everyone got the information about the actual facts behind the power electronics and why it makes the difference here, and hopefully also Danfoss gives you some more light on this one. And if you are interested, please send questions to us. Thank you.
I'd like to start with Martyn and Matt, really. You both talked very much about collaboration, and I think it came through to quite a few other of the presentations as well. Not just collaboration, but synergies between power electronics used for various applications. But I'd like to talk about collaboration, because I think, you know, we're all in this together. This is COP26 that we're running up to. This is net zero. It is the whole world, very much to what Sarah mentioned. Martyn, Martyn Wood says, how does DIT and the foreign direct investments that you're trying to land, how does that help the collaborations or more globally, and specifically, of course, in the UK?
A couple of things spring to mind, really. We've got a whole load of competence here in the UK around certain areas of the value chain. By adding some key targeted companies from overseas into our value chain, we enable the UK to have a more complete value chain and then to play on a competitive footing. I think that's, you know, the predominant thing that springs to mind. The other thing is, of course, within any sector, the opportunity to share best practice, to enable that to spread between partners, you know, I think can be really decisive and really valuable. And just a shout out to your organisation, you know, any companies dialing into this today, the Advanced Propulsion Centre do a great job of connecting people together, and of course we do that to a certain extent as well. But within the core competition of APC, it's a great chance to get involved with the ecosystem and really further your collaboration opportunities.
And Matt Boyle, please. I mean, you talked about collaboration. I think you've been in this space for a long time. How do you see that, and how does, you know, the various investments that you have across the sector, how do they all sort of come back together?
There are a number of factors in collaboration, Dave, that are blindingly obvious, even as you try to address them in a single sector. This is a disruption in industry that hasn't happened in a very, very long time, certainly well beyond my lifetime, and I would suggest even yours. So the disruption is all about we've been going along a nice easy path, nice straightforward path with internal combustion, and all of a sudden everybody's woken up to the fact that that cannot continue, and that disruption means that in various sectors all over the world, in various markets and various sectors, there's a demand for solutions to this stuff. However, there is a finite capacity to deliver. And what you have to do is you have to collaborate in order to maximize the solution for more than one person. And that's why we're very interested in making sure that anything that we develop can be applied across sectors in order to help those sectors who might not have the pulling power of automotive, for example, to have engineering capacity that is very scarce, especially when you talk about the power electronics side of things. So the collaboration, as far as we see, is not only across sectors, it's also up and down the value chain. So we are looking at manufacturing in the UK. We are looking at how that could be achieved by collaboration with people from the Far East and from Europe, who today are not looking at some of these sectors. So for them, it's business growth. So it's a kind of win-win situation.
And Sarah, I just wanted to touch briefly on what you said. I mean, there's a great story around energy generation, but then right at the end you said, well, how about the developing world? And I think so far there's been quite a long sort of story about how the West needs to help the developing world. I'd actually like to twist this question the other way around, because I think Malawi is one of those countries, but there's plenty in Africa where I think distributed energy generation but also payment methods have been on the leading front there for a long period of time. So actually, is there anything we can learn from the developing world where maybe there is a different infrastructure working differently?
For instance, in Africa, in Malawi, where I'm from, this issue of renewable energy is something, the main supply chain for the main supplier of energy in Malawi is hydroelectric power. So in terms of solving the problem of net zero, it is not the source of energy, but it is that they use the renewable energy already in Africa. But where it comes, this issue of achieving net zero cannot be achieved singly in UK by all these technologies and technologies that we have talked about. But it is also to think about how it can be used elsewhere, for instance, in Africa, where resources are scarce in terms of money, for instance, to buy these commodities. If UK is really passionate and like other countries to achieve net zero, it has to think about those developing countries. It has to think about that person in the rural area cutting down a tree in order to get energy out of it. And how can we help such country in developing technologies that are cheaper and affordable for them to solve their problems as well as we solving our problems? And there's much resource available in Africa in terms of minerals and the like. And how can we work together in order to achieve and get those minerals, and work together in the supply chain of UK where maybe such resources are scarce? For instance, work with Congo where they have got carbide and other materials where we can leverage and maybe get these sources, these raw materials, in a much more socially accepted way, and then use those resources in our power electronics and achieve ways where we can both benefit and both have net zero of carbon footprint.
I mean, we all read about, rare earth for magnets. We all read about, the critical materials around batteries. Are there any particular materials that we need to be worried about from a power electronics perspective? So
there are very scarce materials that we have in terms of power electronics itself. I'm not necessarily sure, but there are some mines where, like for instance, the copper belt of Zambia, where it is not necessarily the materials themselves, is how the people in that area obtain that material, because the other side of this is ESG, our social responsibility and governance around those areas. So it's not just the danger of the materials themselves, it's how those materials are sourced as well.
Anyone else that wants to chip in on any particular material for power electronics that we need to worry about?
Yeah, so I think Yeah, there are various precious metals used in electronics. We've got there's an awful lot of silver, gold, platinum, and antimony, for instance, all used in power electronics and power electronics modules. And I think one of the things we can do there, I think, is look more circular at this, at trying to secure our supply by looking at it from an end of life perspective and a circular economy approach. So certainly one of the projects we funded through Drive the Electric Revolution was looking at the recovery of gallium from end-of-life LEDs, for instance. So I think there are also an awful lot of already existing processes out there for recovery of gold and silver from end of life, and I think it comes back to your point on magnets, Dave. And I won't mention magnets again now because we'll go off down a rabbit hole. But yeah, I think if we took more of a circular approach to this, there is a good way of looking to secure a supply for the future.
I mean, the only thing I was going to say was it's about responsible use of this resource. And one of the things that BMW was pushing at the last IAA is their recycling. So we have a big push in the automotive industry now for a design with an eye to end of life. So we design for manufacture. This is important. So good integration means that you're removing parts anyway. So if a component has multiple function, that's really important. So that's good intelligent design. But you also have to have an eye to the design at the end of life. Can you recover the copper? Can you recover the element? Are you not just putting these parts into landfill? Can you reuse those materials? And that's important. I think that's one of the big pushes. Of course, today everybody's focused on the silicon shortage, but that's just responsible use of the materials we have. But in the future, in the next 10 years, we have to look a bit further than this. What are you going to do with these inverters when they become end of life? Are you just going to check them in landfill, or can you extract those materials? Can you remove the plastics and the aluminium and the copper? Because this is really our responsibility to the next generation that follows us.
One thing that perhaps a bit of a parallel with our units going out into service, and if you imagine a gas turbine that could be in service for 25 years, ideally it's a fit and forget part, but the reality is that designing for repair is also a significant aspect of through life, effective asset management, and that can be quite tricky with some of the challenges of microelectronics as we move forward. Certain coatings, which are good, do a really good job from an environmental perspective, so far as water and other such contaminants, but actually really tricky to repair. So it's a real fine balance, and we kind of like to treat our products as a bag for life, if you know what I mean.
Yes, I think that terminology is being used more and more often. Beyond the net zero, beyond the life cycle analysis, there are typically in end use applications a whole raft of materials that should be reused. Sometimes the question is, can it be done so commercially? We'll touch on the chip shortage in a minute, if I may, because I'm interested in that, of course, from an automotive perspective. But before we go there, there's a number of companies on this call that are headquartered overseas, and I'm just wondering, Kimmo, starting with you, well, all of you are very much, sort of really in the R&D, detailed, deep engineering. But Kimmo, can I start with you? What's sort of like the rationale? And please don't say APC funding, because that would not be a good answer. But what's the rationale of actually, doing your work all around the world? It's global, a proper global company. What did you find in the UK to come and do R&D and further business, including manufacturing in the UK?
Yeah, there is two things. Of course, UK has a long history on the automotive part. So you have let's say engineering that is developed, and you can also find a little bit more senior engineers, and also the cost of the engineering is relatively competitive, if I would put it this way. So UK in that regards, if you take the whole Europe, if you compare, for example, Germany, UK is really cost competitive and educationally high position to be in Europe. The question that remains for us for sure is that how competitive can the supply chain be in UK? And that's in our program really the step that where we want to see the let's say push from UK and also really from these programs that are we able to find suppliers that are competitive in the long term. As we are a global company, we cannot accept anything else than to be competitive in the global perspective. So that is something that is still to be seen, and that's where I will push heavily our team to really challenge you also there, that the UK need to step up and be able to show that the supply chain can be built in UK. But if it's not, then it will be done where it is the most competitive. At the moment, what we know is that the R&D capability, engineering, the universities, the cost of the engineering is in a really competitive level, and that's the main reason that we decided to enter. Of course, adding that that Meritor is also heavily involved in UK, and as they are our key customers, we want to be close to our customers.
Excellent. That's great to hear, and it's good to hear how the UK, plays its part in this race to net zero. Matt, if I may come to you, I mean, I've been led to believe that capital investment might well be one of the biggest barriers to get to net zero quicker. You just, heading up Turntide investment and basically came back to the UK to and work with a number of companies that you know well and trust. How, from an investor perspective, how is the UK viewed, and how can the UK really play a significant part in this race to net zero, you think?
So it's a bit like Kimmo's just said. One of the great attractions for the investors in Turntide was that the capability already existed in the UK. Finding it in the kind of critical mass volume that they acquired is actually quite difficult across other regions of the world. So picking up 140 power electronics machines and drives engineers in one fell swoop was quite an attractive aspect to the investment. But the other thing is, the certain aspects of what these businesses have been doing over the years is they have been manufacturing. And the one I'm best known for didn't manufacture in the UK, but it has a very active set of suppliers who would be interested in coming to the UK because that's where the capability exists. And kind of the last thing for me, Dave, is it makes an enormous amount of sense if you're developing the IP that you put the manufacturing facility right next door, because the support of the manufacturing of some of this stuff is actually quite intense, and you really want your manufacturing facility as close to where you develop the IP as you possibly can, and that helps accelerate the whole development cycle.
Yeah. So again, I suppose we hear more about the system. I mean, Kimmo very much touches on the supply chain. You talk about skills and skills developing, new technology, and then manufacturing. So having things in close proximity seems to be, despite having lived through a pandemic and all, looking at each other through a little window frame, still seems to be very, very important. And I suppose that's what we learned from the first industrial revolution as well. Everything started to coalesce around certain levels of strength. So on that supply chain, one of the questions that come through is, what can we learn from the most recent chip shortage, and what does this mean to us? And David is laughing, so I'll start with David. I'll pick on David for starters.
For us, one of the big things was having access to the UK talent, and this is, I think John's on the line. We have a company, Custom Interconnect Limited, and they have built really rugged electronic systems. And for us, I want to bring those to automotive. We're not traditionally builders. I mean, we build rugged systems, but not rugged power electronics. And for us, having access to companies that have a really deep knowledge of these technologies and the universities will help us bring those talents. And that for me is the real key thing. This is why we're here. This is not just about it's not just about funding something. It's about having access to that talent pool, and we have a small team, and this is also working very well for us. So working with the Catapults, this is why BMW is sitting in Oxford today doing power electronic design. And I'm really interested to maybe have following up discussions with Kimmo, because we've looked at modules before. We're also looking at a standardized package, and I'd like maybe we can have a chat with him about feeding in for this, because this is an enabler for us. It's making sure that accelerating this, it's not enough to design the technologies, we have to make the customer want them. And you do that by bringing them to market quickly. And we're in a situation right now where these technologies are moving faster than we can put them into the vehicles. So this is one of the UK is very good at doing this. It's really good at doing fast development and fast turnaround of concept to market, and it's not traditionally how we do it. So this is why we're here.
Yeah, happy to work with you, Dave. No worries on that. Really happy to share this. And of course, for us, more standard the module is, the more easier the life is for us. So
Exactly.
you know it really well. Touching a little bit about the component shortage, as of course that's my daily pain in also nights. Nothing else to do than having the escalation meetings with all the suppliers and explaining to customers why we are not able to deliver some of the parts on time. And it is just that what we can learn. Companies in this world, they are so lean that the rapid changes that comes in the system are not be able to be let's say reacted. And what we need to learn is that the companies who are more sense of urgency are the winners, and that's at least for us in Danfoss Editron. We need to be much more faster and better to react on the situations and secure our pipeline. But at the same time, I think that also it goes for BMW, and we try to do the same thing. So in the next change, we are on the same position. But it's actually not about the raw materials. It's just that the market is growing so fast that the fabs are not there, and it takes about 2 years to bring out the fabs. And when there is money and the engineering, it will happen. And when we have the fabs in place, this will go out. And this is just a short dip in this market, which is a good thing in that regards that finally the change to electrification happened. I can tell that I have been waiting that for 10 years at least, trying to cope with the promises of the OEMs that yes, next year we will release the electric vehicles, and I don't know. I can tell that it's about 5th time that we have the discussion, and actually now it's happening finally. So I'm happy regardless of the problems that we are in this situation.
So I think what you're saying is very much a race to net zero. We need to move faster. We've had a couple of false starts maybe where the market wasn't ready. To get there faster, it seems quite clear that more investment is required. It's predominantly private investment, and that's required quickly because it does take time. And I think what you also say around supply chain, that is not just about ruggedizing the power electronics, but also the supply chains to make sure that you can deliver on time and on cost. So I think that is, yeah, I think it's been great to hear from you all. I think you've all been contributing a lot to my knowledge, and I hope to the people on this webinar. And I think it's just a big thank you to all for doing this. And hopefully we're getting into COP26 where there's a big step change forward to actually meeting net zero. So on this road to COP26, this is a series, as I said before. Next week we have 2 further sessions on. The first one is on Tuesday, the 12th of October, on e-machines, which I think is a nice follow through from electronics. And on Thursday, we have one on investment led by the KTN, because I think that's another sort of key enabler to make this move faster. So with that, I have no further. I thank you all for your contributions, and I hope that everybody watching this has really been enjoying this. So with that, thank you ever so much, and goodbye.